Okay, so June 2014 M1 on accelerated motion. So it says a vehicle travels on a straight horizontal road. It passes point A with a speed of 10 meters per second. It accelerates at a constant rate for 21 seconds until it reaches a new speed of 24. Then travels for t seconds before decelerating, coming to a rest at B. The time taken to decelerate is 16 seconds. Calculate the magnitude of the acceleration of the vehicle. Now then, it doesn't ask you until part C to sketch a velocity time graph. But I always find it a lot easier to do on these questions the velocity time graph first. So I'm going to start by doing part C first. So, sketching this out. Just going to stick this sheet down a second. So it stops moving. So we've got velocity time, and I'm going to have a go at doing this. So we've got starts with a speed of 10. So our graph is actually going to start at 10 this time. Accelerates for 21 seconds, so accelerating, diagonal line, for 21 seconds. So we reach a time of 21. And this is in seconds, and this is in meters per second to -1. Then it reaches a speed of 24, so we put on a new graph of 24. Try and do it a bit more accurately than I have done there. Then it travels at a constant speed for t seconds. So this gap here is going to be t seconds. So this is 21. This is t, so we reach t plus 21 here. It then decelerates, coming to a rest at point B. The time taken to decelerate is 16 seconds. So let's just make a bit of space here with this. This time here was 16 seconds, the time it took to decelerate. So adding 16 onto this is t plus 37 by adding on 16. Okay, now we've got our graph. I think it's much easier to work out some of the questions. So part A, calculate the magnitude of the acceleration. So the acceleration is this part of the graph. So for part A, I'm going to write down everything that I know. I'm going to write U, V, A, S and T. So U, the initial velocity was 10. The final velocity was 24. The acceleration we don't know, so trying to find. Distance we don't know. And time was 21. So I'm not going to use this one. So I'm going to use the formula from the SUVAT one. V equals U plus AT. Now putting in what we got 24 equals 10 plus 21. A we don't know, and T is 21. Working this out then, we'll end up with 14 equals 21A. So A is 14 over 21, which simplifies down to 2/3. Okay, so 2/3 meters per second to the -2 there. Part B then says, determine the distance taken for the vehicle to decelerate to rest. Now the deceleration is just this part here. So we're just trying to find the distance of this part of the graph. Now there's two ways you can do this. You can either use an equation, or we should know that distance is the area under the graph. So if we look at this part here, it's just a triangle. So for part B, let's move this up a little bit. Trim the distance, I just want to work out the area of this triangle. So the distance is the area of the triangle, which equals a half base times height, which is a half. The base here, gap between here was 16. It tells us in the question that it decelerated for 16. So half times 16 times by the height, which is 24, which gives us an answer of 192 meters. That's probably the easiest way to do that one there. Part C we've already done here. Now we're going to look at part D. So Part D says, given that the distance between A and B is 15,000, find the value of T. So part D then. What they've done then is they've told you that this distance here is 15,000. Now we cannot use the SUVAT equations for these because the acceleration changes over the time here, as does the velocity as well, and the time scale. So we can't use a SUVAT because it varies. So instead, to find the distance, we need to look at each of the shapes. So we've got trapezium, rectangle, triangle. So we can say that the area is equal to the area of the trapezium plus the area of the rectangle plus the area of the triangle, because this graph is split into those three shapes. So we can do 15,000, area of the trapezium, half A plus B, so this is A, this is B, so A is 10, B is 24, times by the height, which is 21. Area of the rectangle, base here is T, height is 24, area of the triangle, base was 16. You've actually already done this one, haven't we? We did the area of the triangle, but yeah, so we can just put this straight in as 192. So working this out, this is going to give us, we work out a calculator, work that out, half it times by 21 would give us 357 plus 24t plus 192. And then it's just a case of working all these parts out. So adding these two bits up, and then taking them away from there. So we get 15,000 equals 24t plus 549. Taking the 549 over gives us 24t is 14451. Let's check that. 14451. Divided by 24, which is going to give us an answer of 602.125. That's our final answer there.